The types of problems we're working on in this section will be trying to find x values that satisfy expressions like x plus 1 is greater than or equal to 0, which hopefully isn't very hard to do, and you can see that the techniques we used earlier on in this chapter for equations still works more or less, just with an important adjustment about how much we can possibly get that satisfies that. However, before getting into that, I'd like to spend a little bit of time setting down the notation that we're working with. That is, putting in the backstory here, where the idea of equality in a mathematical or a numerical context should make sense. It should be reasonable, sensible even, that if we have two amounts of something and we want to say that they are the same, we'd like a notation for it. We'd like to be able to talk about those things as being equal to each other, even if it's not quite obvious that they refer to the exact same amount of something, where the notation that we use with the two bars comes from the Welsh mathematician Robert Recorde, in particular his work The Whetstone of Wit, where what he said was, and to avoid the tedious repetition of these words is equal to, I will set, as I do often in work use, a pair of parallels of twin lines of one length thus, because no two things can be more equal. And I'm sorry if I offended anyone watching this who is of a Welsh background, but obviously the wording is a little bit different from our modern English. I stumbled over it a little bit there, but the point is that he's saying, what could possibly be better to represent equality than two parallel lines? Represent the same amount of thing, they go in the same direction, they do the same thing. So, in math, we take them to represent any situation where we are looking at the same thing, maybe in a slightly different way, through a slightly different lens at a slightly different location. And the idea of inequality is similarly logical, but how we end up with this notation where we have this symbol for less than, this for greater than, this for at most, and that for at least, where again the wording can change a little bit, whether we want to say at most or less than or equal to means roughly the same thing. But when we're talking about these inequalities, they have roots that actually date back to the Greeks, and this notation in particular comes from the work of Thomas Harriot of Britain, where he is said to have been inspired during his work in mapmaking for the Virginia and North Carolina colonies by tattoos on the Carolina Algonquin indigenous peoples, where for us, we have these symbols that we work with that came from that notation of Harriot's. And if we're going to talk about what happens with inequalities, we're going to talk about what solutions we can possibly get for inequalities, we need to set another important piece of notation called interval notation in order to be able to talk about the windows of values we possibly get, because hopefully, even though we haven't already talked about it very much, you should be able to tell that something like this isn't just going to be solved by a single value.